What public transportation do all parallelograms use? They use the rhombus. Get it? Rhombus, rhombi. But right now we're going to focus on rectangles, and we'll get to the rhombus later. So you've known about rectangles since elementary school. It is a rectangle is a parallelogram where all of the angles are right angles. So I'm going to look at the diagonals of rectangles by slicing this rectangle two different ways. I'm going to do diagonal DB on the top rectangle and AC on the bottom. Now that gives me two different triangles, ABC here and DAB up here. And I can tell you that they're congruent. Now why are they congruent? Well, AD and BC are congruent because opposite sides of a rectangle or any parallelogram are congruent. Also, AB is congruent to itself because of reflexive property. Now you can see that I have side, angle, side, and here I have side, angle, side. So the two triangles are congruent by side, angle, side theorem. So why was I trying to show these two triangles congruent? Well, I'm trying to get to the diagonals. Well, if the two triangles are congruent, all the corresponding parts must be congruent. That means that DB is congruent to AC since those are both the hypotenusae of those right triangles. This leads to the theorem that if a quadrilateral is a rectangle, then its diagonals are congruent. Now let's look at the converse. If the diagonals are congruent, does that mean that a quadrilateral is a rectangle? Actually, it doesn't, and a lot of it has to do with this word right here where I say quadrilateral, all right? So that's any four-sided shape. So I'm going to come up with a counterexample. Do you see this isosceles trapezoid? Diagonal BD and diagonal AC are congruent. So that means the diagonals of an isosceles trapezoid are congruent, but that's not a rectangle. Now, if I had reworded this to a parallelogram, I couldn't have used the trapezoid as a counterexample. It would actually be a true statement. So let's look at this example in rectangle ABCD. So AC is a diagonal and BD is a diagonal. See how they kind of skip over each other. I want to find the length of the diagonal. And I know that AC is x squared plus x minus 9 and BD is x plus 16. So I set the two sides equal to each other. And I subtract x from both sides. And then I add 9 to both sides and I get x squared equals 25. Now this is interesting. We haven't done this very much, where we've solved for a squared x, where in reality I can have two different answers. My answer can either be positive 5 or negative 5. Let me do the problem with positive 5. In that case, I'm going to take BD, which is easier than AC, and say it's 5 plus 16, which is 21. But my other option is BD could be negative 5 plus 6, which is 11. So in reality, I have two possible answers on this. It's either 21 or 11. So let's go ahead and reflect. Explain why changing the word quadrilateral to parallelogram makes the converse true. And the original was, if a parallelogram is a quadrilateral, then the diagonals are congruent. The converse is, if the diagonals are congruent, then the parallelogram is a rectangle.